Hello everyone again, and welcome to Permutations and Combinations exam questions number 8. Right, so for the first question, to summarise, we have 4 balls and 4 buckets. And if we randomly put the balls in the buckets, we want the probability that no ball is in the bucket of the same colour. So let's start by labelling the balls from B1 to B4 and the buckets from K1 to K4. Now we know B1 cannot go in K1, so we're going to start by putting B1 in K2. Now if we do that, we can arrange the remaining balls in the following 3 ways, making sure that no ball is in the same coloured bucket. Next we could put B1 in K3, and again we find 3 different ways to arrange the remaining balls, making sure none of them are in the same coloured bucket. And finally we can put B1 in K4 and we get the final 3 arrangements. Therefore, we know there are 9 ways that we can arrange the balls in the buckets so that the colours don't match. Now we know the total number of arrangements is 4 factorial because we have 4 items to rearrange. Therefore, the probability is 9 divided by 4 factorial. In the next question, we're picking 2 teams of 6 people at random. We have 6 men, 3 women and 3 children to choose from. What's the probability that both teams contain women? To make it easier, we're going to write down the available people like this, as they are either a woman or not woman. So if we start by selecting the first team of 6 using no women, for the first person we'll have a choice of 9 people from the available 12, and for the second person there'll be 8 people from only 11 people left now. Then we'll have 7 people to choose from out of the remaining 10, and 6 people to choose from the remaining 9, and so on. So we end up with this calculation. The 9s cancel, the 8s cancel, the 7s cancel, the 6 and the 12 cancel to give a 2 on the bottom, the 5 cancels with the 10 to give a 2, and the 2 2s can cancel with the 4, so we get 1 over 11. So that's the probability that the team has no women. So the probability of the team having women is 10 over 11. If you want to read the next question in full, please pause the video now. I'm going to summarise the information we need as we need it. So we have the letters above written on separate pieces of card, and we are asked to find out the probability that if we pick these cards randomly and lay them out, it will spell statistics. Now there are 10 cards, and therefore the total number of ways we can choose the 10 cards is 10 factorial. But how many ways are there that it will spell statistics? There isn't just one way that we could spell the word statistics with these cards, because there are 3 S's, for instance. If we label them 1, 2 and 3, we can see that there are 6 ways, or 3 factorial ways, of organising those 3 S's. And the word would still spell statistics. So we have to times it by 6. But there's also 3 T's. So using the same logic, we have to multiply by 6 again. And there are 2 I's. So those I's can be either way round. So you could have I1 and then I2 or vice versa. So we also times by 2. So the probability is going to be 6 times 6 times 2 divided by 10 factorial, or 3 factorial, 3 factorial, 2 factorial over 10 factorial. And this gives 1 over 50,400. Next, we're asked to work out the probability that the 3 T's are together. Well, if we group the 3 T's together and treat them as one unit, we have effectively 8 items to rearrange. And the number of ways we can arrange 8 items is 8 factorial. However, as we spoke of in part A, if we have 3 T's, we can organise them in 3 factorial ways. So we have to times this by 6. So the probability that the 3 T's will be together is 8 factorial times by 3 factorial divided by 10 factorial, which reduces down to 1 over 15. Next, we want to find the probability that the arrangement starts with cat. So if we put CAT at the beginning of the arrangement, we've got 7 spaces to fill. So we'll have 7 ways to choose the next letter, 6 for the next, 5 for the next, etc., which is the same as saying 7 factorial. However, we can change the T in 3 different ways for the CAT. we have to times that by 3. Therefore, the probability is 7 factorial times 3 divided by 10 factorial, which is equal to 1 over 240. Another way to work this problem out would be to say that to choose the C to be at the beginning, you have a 1 in 10 chance of picking that from the 10 letters. Then there's 9 letters left and there's only one A, so you have a 1 in 9 chance to pick the A as the second letter. And you also have 3 T's and 8 letters left, so you have a 3 in 8 chance to choose the third letter. And if you work that out, it also comes to 1 over 240. Next, we're asked to work out the probability that the arrangement ends in an S. So if we write all the spaces down for the 10 letters and place an S at the very last letter, we can see that there were 9 other letters to arrange, so that's 9 factorial, but there are 3 ways to arrange the S, so we have to times that by 3. So the probability is going to be 9 factorial times by 3 divided by 10 factorial, or 3 over 10. Alternatively, you could say that there are 10 letters and 3 of them are S's, so there's a 3 in 10th chance of choosing an S for the very last letter. Thanks again. Don't forget to hit the like button if it's been of some help, this video, and I hope to see you on the next one.